Now that we've got some of the basics out of the way, we're going to use a little matrix in the rest of this module, or at least in a good portion of this module. And the matrix is going to be made up of three basic categories: tolerance to downtime being high or low, tolerance to data loss being high or low, and tolerance to reduced capacity being high or low. And I'll get into what the various meanings of those actually are. We're going to group them together as appropriate, and then we're going to explore each one as it relates to MongoDB. I'm going to draw that matrix for you now. Okay, so here we have our matrix, and this is a tolerance for data loss, tolerance for downtime, tolerance for reduced capacity. And the idea is here to create a matrix that sort of describes some of the more common concerns and common scenarios that you run into for applications in terms of disaster recovery. What I'll just do here is talk about the two sort of binary options in each category. If you have a low tolerance for data loss, and let's face it, most people in an ideal world are going to have a low tolerance for data loss. You don't want to lose your data under almost any circumstances, but there are some cases where losing data is not the end of the world. Think of a caching system where the system of record is a relational database, or the system of record is a bunch of flat files. So if you lose your data at the caching layer, which in our case could be a series of MongoDB primaries, for example, you lose your data at the caching layer, it's not the end of the world. You can just wipe that out, stand up a new node, or restart that node, reformat it, and repopulate your data from that system of record. So there are valid use cases where you have a high tolerance for data loss. For the most part, you're going to be dealing with people who don't have a high tolerance for data loss. In other words, they don't want to see data lost if at all possible. On the downtime side, again, you may have a high tolerance for downtime. Seems odd. Why would people have no problem with their system not working? Well, you can imagine that if it's a business system and it only actually needs to be up between the hours of 9 and 6 or 8 and 7 to put in some padding, you might have a very high tolerance for downtime as long as it's not between those particular hours. So needing to take a system down, say a batch processing system would be a classic example of this kind of thing. Needing to take a batch processing system offline for 4 or 5 hours a day, which would be somewhere between 18 and 25% type of downtime on an ongoing basis, might be fine. You might have no problem doing that. However, a lot of the online systems, a lot of web-based systems are going to have a very low tolerance for downtime. They're going to keep those multiple nines that we talked about in our last discussion. They're going to want to have as many of those as possible in an ideal world. So you're going to have to make this call based on the application and its requirements and what it's actually doing. And then, of course, how much is downtime actually going to cost you. Reduced capacity, this is a somewhat more nuanced argument. Can you deal with having something at reduced capacity? What does that mean? Well, consider if you've got some very, very expensive hardware running in your primary data center, big servers, very expensive, high power consumption, the whole thing, and you need those servers. They're running at somewhere between 60 and 80% at peak. You need those servers to be able to service your peak, and you don't really have a choice. However, you've decided that it's too expensive to have another set of them running idle somewhere else, just sitting there and waiting to be engaged. So you've got a high tolerance for reduced capacity in that case. You've decided that you're okay with a failure scenario resulting in less capable machines taking over. Maybe that means your application is slower. Maybe that means less people can use it. Maybe that means that you actually are going to suffer through your peak usage, but you might be fine between the hours of midnight to 12 in the day, and then your usage really starts to pick up. So it still gives you a 12-hour window to get things back over to your nice, well-provisioned primary site. So operating at reduced capacity, is that something you're willing to accept? In which case you can make some cost savings, you can have lesser systems ready to take over and shoulder the workload if your primary systems go down. Or do you have a low tolerance for reduced capacity? Do you absolutely have to have consistent performance all the time? Is latency a key metric for you? Do you need it to be predictable? And there's plenty of applications out there that don't deal well with variable latency. The classic example, even in day-to-day use, would be things like voice applications and video streaming. If there's a constant latency of 100 milliseconds, and that's fine. If the latency jumps all over the place from 10 milliseconds up to 500, down to 10, up to 1,000, down to 2, up to 5,000, most applications are going to struggle with that kind of variance, and if you need to keep that nice and on an even keel, then going to a reduced capacity scenario may not be something that you're willing to do. So there's 8 combinations because we've got 2 values and 3 categories, so 2 to the power of 3 we have 8. But we're actually going to combine a few of these when we're talking about them. So sort of the 5th row to the 8th row here, that's going to be our first group. We're going to cover that one first, go through a scenario where you've got a high tolerance for data loss. We're going to group those together because the data loss one is really the sort of the main driving factor there. Then we are going to group together these two, where you've got a low tolerance for data loss, you've got a high tolerance for downtime, and your reduced capacity sort of switches between two depending on what your actual needs are. So this is group 2. And then finally we're going to group these together, group 3, where you have a low tolerance for data loss, low tolerance for downtime, but your reduced capacity piece is somewhat variable, so we'll talk about those two.